Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. First will be Linux kernel, second one will be VirtualBox. Third one I would like to add a WSL. Then I'll teach you Linux commands. Okay, and after that shell scripting and then script CRI scripting, and then finally I'll teach you Vagrant. So that is the topic for the day. Okay, so Linux kernel, which is a theoretical, so you need to understand. If you are trying to, prepare for the top broad companies, so most of the time they'll ask you Linux kernel. So 30% of the topics will be related to Linux kernel, and after that they'll ask you to write some code. Actually, could be in Python or something like that. Okay, so let's get started. So, what is Linux kernel? So more or less you might have heard about it, but today we'll little bit spend time to deep dive into that. So Linux kernel is a computer program. So what basically it will do, it will help you to talk to machine. That means you understand one language, but machine understand the language of 0 and 1, correct? So 0 and 1, that's called bit language. So kernel is a kind of program which will help you to translate your language to machine language and machine language to human language. Correct now? All of you?
Yes.
Yeah. So, yeah. So if you look at this here, you have a software kernel, and then kernel also helps you to manage all the hardware. Hardware you may have CPU, RAM, disk, devices, and all stuff like that. So the question is where the kernel program runs. So kernel program basically runs in the memory. So it is a portion of the operating system code that is always resident in memory and facilitates interaction between hardware and software component. So when the kernel program runs, just a second guys. Okay, so just a second. Yeah. So where the kernel program runs, the kernel is one of the first program loaded on startup. So what happens when you start your machine, laptop or VMs? So the first program which get loaded after the bootloader is kernel program. So if you see that these are the types of kernel which we have: microkernel, monolithic, hybrid, nano, exo, and many others. Which one is we are using? Which kind of kernel? Any idea? Any idea which kind of kernel we are using? Hello, are you there?
Mm. No.
Yeah. We are using monolithic kernel. Okay. In fact, Android, you know that, right? Android, you must be using if not iPhone. Then Android is also is a kernel only, built upon kernel. So what is the primary role of kernel? So primary role of kernel is like managing a task. Task management means, look at this here. These are the tasks here you have. So you're comfortable with this one, right? All of you.
Yep.
So these are the tasks which is managed processes. Also managing the devices and manage device input output like keyboard, mouse, and all of the devices. Also memory management means which process should get how much memory and all kind of things. Timer management, synchronization, and communication. So these are the primary role of kernel. So here you look at this full kernel control all hardware resources, memory, device driver, and optimization utilizations and all stuff like that. So yeah, CPU and cache uses, file systems, network sockets, memory management, peripheral devices, input output, and stuff like that. Anyone have idea who's this guy? Anyone?
Linus Torvalds.
Yeah. So no, this guy actually.
No idea.
Yeah,
So
Linus
this,
Torvalds, I think. Yeah.
yeah, true. Yeah, he's the one. He's the father of
Linus.
Linux. Yeah, and he's the father of Git also. I'll teach you Git in the upcoming session. So yeah, so he is the father of Linux kernel. So yeah, we understood that. So Linux kernel is a free and open source monolithic modular multitasking Unix like operating system kernel. It was originally authored in 1991 by Linus Torvald and so on. Okay, so use of Linux kernel everywhere. I think if you are thinking Linux, we can use only for server purpose. No, all the Android devices developed in Linux only. Okay, so Android is developed based on the Linux. So Linux is used in the mobile also. Embedded devices means lots of hardware will have an embedded, very lightweight kernel, or personal computing's the one which we are using for, and servers, same frames, supercomputers and all. Okay, so where the Linux kernel runs, I told you, right? So just after the bootloader, Linux kernel get loaded in the memory. But what is a bootloader? So bootloader is also called as a bootloader or boot manager or bootstrap loader. Its multiple names are there. This is also a computer program. Okay, but that is responsible for booting a computer. So when you bootloader, you can consider as like BIOS. When you switch on the machine, some program get loaded, uh, that's under the BIOS, which is called it a bootloader at a high level. So bootloader, you can decide what should be loaded in your system, kernel or some other stuff also you can decide. So here we have some content related to how bootloader works. Right now this is not more useful, but just read this middle section. When a computer is powered on, it typically does not have an operating system or is loader in RAM. So bootloader decide that which kernel to be loaded, operating systems and all. So look at this flow: power on, then ROM code got added, random only memory code, and then here you have booting devices to bootloader, bootloader load the kernel, and then after that your operating system is ready. This is the flow happens. Okay, so power on, load bootloader in ROM, load kernel code in RAM. In this is simple way. Little bit in detail right now. You don't need to understand this. Okay, so at a high level, we understand that what is kernel, what is the role of kernel, where it is get loaded, and when it gets loaded, and all stuff like that. Any questions so far, all of you? All of you?
No.
Okay, so now this is also important topic, and it's an interview question. I mean, people will ask you interview question. So in kernel, now talking about the kernel, all the program runs in a two space. Primarily is divided into two space. One is kernel space and another one is user space. Okay, please remember the kernel space and user space. So what is kernel space? What is user space? Let's understand that. So computer OS usually segregates virtual memory into user space and kernel space. That means all the memory allocations to the programs segregated into two space, user space and kernel space. So here the kernel platform perform its tasks. What are the tasks kernel it perform? I showed you: task management, device management, interrupt handling, communications, and all many things actually. So kernel perform its tasks such as running processes, managing hardware devices such as hard disk, and handling interrupt, but in this protected area called kernel space. Okay, so that all the kernels, whatever is doing, performing their tasks, where they are doing in kernel space. But in contrast, all the programs you you run, I repeat, you means your browsers, notebooks, editors, some programs, chat machine, anything you run, that runs in the where user space. So in contrast, applications programs such as browser, WordPress processes, or audio and video players use a separate area of memory. So user space. So virtual memory divided into two part: kernel space and user space. Are you understanding, all of you?
Yes. Rajesh.
Yes.
Okay, look at this. The Yeah, so why kernel has user space and kernel space? You'll ask why they divide that. Some programs they run in protective area that is called kernel space and user space. Okay, so the reason is what happens. Uh, Users run multiple different types of applications, and because of your activities, kernel should not shut down. I mean, operating system should not shut down. You should not, you know, hack the kernel. You should not hack the operating system. You should not destabilize the operating system, because user can do anything knowingly or unknowingly. So they should not impact the kernel for security reason, hardware protection, and stability of OS protection. So for that, what operating system has divided that two areas: one is user, one is kernel. So all the program which is related to the operating system, they run in the kernel space. All the programs they run, they want to run for the user space. So here if you see, primarily this separation serves to provide memory protection and hardware protection from malicious or irrelevant software behavior. The separation prevents user data and kernel data from interfering with each other and causing instability and slowness, as well as preventing malfunctioning application from affecting other application or crashing the entire operating system. Did you understand that? Why do we have a two space? All of you? Hello?
Yes. Yes.
Okay. So now look at this here. This is the visualization. There's a kernel space. Kernel runs in a supervisor mode and his access to the user section as well. And kernel memory map is fixed. Applications from the user runs in a user mode with limited privilege. Each application has its own virtual memory map. Okay, so in all this thing, user space and kernel space, all this thing is managed by supervisor, which is there in the operating system. So now the next question, this is again interview question. They will ask you, hey, how this your program can talk to the kernel? Because here you see user and process. User process means this is a Firefox. You see here, this is user process. If you go to the detailed one, see here. So let's say go to meeting. Right now I'm running, or let's say Google Drive. So this is the user process. You see here, Rajesh Kumar is running. So how this process will get RAM? Here you see CPU allocation and memory allocations. How they will get it? Correct. So here you see this is the user process running in the user space. They need a CPU and RAM or disk or whatever it is. How do they get it? So they get it through the system call. If they'll ask you how do they get it? System call. And they ask a kernel space which is managing your hardware, RAM, disk and all for that. Will you remember this, all of you?
Yes.
This is called system call. So now here if you see uh, here one application which is bash, okay, and they are talking this using system call. Multiple methods are there in the system call. Get PID, open, this one of the examples in syscall. So they say get PID. So who's managing the process ID? Kernel space. So they get the PID. After that, when you run the command cat etc host, this is a user command, okay? Cat is application and arguments you are passing. So now this file is hosted, which is by kernel, right? Storage is managed by kernel, storage system, different types of it. So here you will make a syscall and the open method, and you'll try to open that file which is hosted in this one. Are you understanding, all of you?
Yes.
Okay. So yeah, kernel space which runs the device driver, generic services, system interface, and user space you can run whatever you want. Okay, so this is also a little bit of explanation about user space and kernel space and so on. One more image for that. This is a little bit detailed one, which are the method it's used for the you know system call. So all this stuff. Okay, so all of you have understood that space concept, all of you.
Yes. Yes. Yes.
Okay, so Linux architecture. This image you might have seen a lot of time. So here hardware on top of that kernel, on top of the shell, top of that all these applications which you have. Okay, so between the kernel and the user, system call interface is there. See that? which basically helps you to access complete resources by the users. Okay, so in computing, a system call, commonly abbreviated to syscall. System call, syscall, both are same, is the programmatic way in which a computer program requests a service from the operating system on which it is executed. It may include hardware related service, accessing a hard disk or devices, creation and execution of new processes. Yeah, new processes means if you want to run new application or something, that is also done by syscall. And communication with integral kernel services such as process scheduling and so on. Okay, so in most systems, system calls can only be made from user space processes. Okay, so system calls provide the service of the operating system to the user program via API. So the system call make a API call to the different spaces and do the work. And these are the services provided by system call. And this is a little bit more discussions of this is called. Okay, so type of system calls: process control, file management, device management, information maintenance, and communications. Okay, so here next topic is how system call works and so on. So this I'll not get into the detail because you don't need to know so much in depth, but if you have a interest, you can refer this. Okay, so now this is done. Hmm. So this is important, process control. So here if you see that example of system call like process control, file manipulation, device manipulation, and so many. And these are the method. This is for Windows and this for Linux. If someone will ask you process control, what exactly is doing? Forking, exiting, and waiting. For file manipulation, for device manipulations, and so on. So this table is very important for Windows and Linux users as well. So for the system call in terms of process control in Linux, here you see that every process is getting created, then ready, it is running or waiting. Running can be waiting and then terminated. So these are the workflow for it. So you see here example for system calls: process control, exiting, running, waiting, and again here running and terminated. Okay, so this just at a high level you just need to remember and so on. So these are the method which is available for process control. Okay, so now this I will leave it as it is. I'm just ignoring some of the slides because too much. Huh. Next one is process and thread. So system call is managing lots of things, and one of the thing which is managing is process management. So we need to understand what is a process and what is a thread. That is the most important one. So here you see that one process which is managing multiple thread. Now what is a process, what is the threads, we need to understand. Here if you see that CPU empower the process, and process you have a multiple thread. Okay, so what is a process? So process is a computer program under execution. So this process, it can be computer program run by kernel also, or you also user program also. So process is a computer program under execution. Linux is running many processes at given time. See, you can see that it's easy way. In Windows, these are the process table. Linux also ps-ef. If you do, you will get a process table. So these are the process running. Some of the process, if you see that, is run by local user. Some of the process is run by network user. Some of the process run by Rajesh. So many. And then system. So these are all the process which you are running in the machine right now. You can see it. Okay, so process is a computer program under execution. Linux is running many processes at any given time. We can monitor them on a terminal using ps command or on the system monitor UI. Linux processes are isolated and do not interrupt each other execution. Remember that this is important question. I mean things. Each processes are isolated and do not interrupt each other execution. Means nowhere they're interfering each other. Okay, so more about the process. With a PID, we can identify any process in Linux. Okay, PID means
Process
you see
ID.
the PID, yeah, process ID. You see that none of the process you will see with the PID. If you look at it a little bit carefully, though I'm talking about Linux but showing you on Windows for ease of understanding. If you see it like a little carefully, these are the process you have attached PID and running or not, and here user, and then CPU allocation, memory allocation, and so on. So every process attached with some user and PID and so on. Okay, so now you understood the process. Now you might have seen that in the images, each process you have a multiple thread. Okay, so what is a thread? Let's understand. So basically thread is a lightweight process only. Thread is also light a process, but it's a lightweight. Lightweight in terms of, so process consume little more CPU and RAM, but thread consume lesser CPU and lesser RAM. Why? There is a reason for it. And the reason we need to understand. This is an interview question. They'll ask you. A process can do more than one unit of work concurrently. One unit of work concurrently and creating one or more thread. So one or more work means, see, if you have opened the browser, Firefox. But in Firefox, you might be opening multiple thread. Thread means Windows, right? New tab and browsing, downloading, watching, everything you are doing in one browser, right? Correct now? So that is kind of thread. Thread process can do more than one unit of work concurrently by creating one or more thread. This thread being lightweight can be spawned quickly. Spawn means, see, the problem in the system is CPU can be empowered to only at a time one process. Yeah, we feel as if, see, think in this way. We feel as if we are running everything, but actually no, it's spawned actually. So if you see that here, one thing I want you to note it down and observe that, which is CPU. Did you notice something here in CPU only? Anything you noticed?
Allocation changes.
Yeah. So if you see that here, CPU can be allocated only at a time to one process. Okay. And what happens? This CPU allocation switches the context very fast. So right now, you see, you might be thinking I'm running everything. You see that this one also, let me close this editor, that editor, but it's not exactly. Only the thing which is running, which is you are consuming it, and those running things only consume the CPU. That's the reason you see that suddenly it changes actually. See, everything is else. My browser is also running, and GoToMeeting, the other things also running. My Chrome is also running, but it's not using CPU. Why? Because we think it's running, but it's not running because they are not demanding CPU. So only things which is demanding CPU will sorry, will be running at the time. So multiple process has to run at a time. So for that, but CPU can be given only to one at a time. So this is called you know process switching, context switching. Okay, so that is a problem. So here what is happening, uh, a process can do more than one unit of work concurrently by creating one or more threads. These threads, being lightweight, can be spawned quickly. That means in one process, if you have a thread don't need to no need to get the I mean process context switching cost is lesser. That means the time is lost from the transferring the CPU from one process to another process is lesser. In the thread, it's not like that. So let's see an example and identify the process and its thread in the Linux user ps. This is the Linux command to see the list of processes running your system. So if you see that PID, LWP and NLWP. So PID will help you to understand the PID of this process. LWP will tell you for that particular process how many unique thread you have it, unique thread identifier inside the process. And then NWP will tell you number of threads for a given process. So look at this here. Here, this is a Linux one, screenshot LWP and NWP. These are the PID, and here you see LWP and number of thread which you have 4442, something like that. So you can identify how many thread, how many process, and stuff like that in Linux. Okay, so single threaded process, that means when you have one thread in one process, so any thread created within a process share the same memory and resources of the process. In a single threaded process, the process and thread are same, as there is only one thing happening. We can also validate through this. Multi-threaded process. In a multi-threaded process, the process has more than one thread. Of course, it is like that. Such as process accomplishes multiple tasks simultaneously or almost at the same time. As we know, threads share the same address space of this process. Therefore, spanning a new thread within a process becomes cheap. Cheap means it's not required more CPU and RAM for creating a more. See, to creating a process, you need a CPU and RAM. So context switching happen. For for creating a new thread, you don't need that allocations because this thread are using the same CPU allocated and memory allocated by the process to the process. So this is the system resources compared to starting a new process. Thread also can switch faster. Mind it, I was telling you, right? Thread can also switch faster because they are also already using the process resources compared to the process in the CPU. So process here, switching is, see, look at this switching. CPU switching is happening. This is costly. So that way something gets stopped, something gets started, then something stops, something gets started. So this is a sequential CPU allocation. But because you have a thread, it's not happening. It's a little bit less expensive. Okay. So thread has only one stake in the memory and they share the heap resources, process memory with the parent process. Look at this here. Here I have a single threaded process, single thread, and they are all this is which is allocated to the process sharing that thread. Now multi-threaded process, whatever allocated to the process, there also each thread is shared also this way. Okay, so this is done. Huh. So this will be interview question, so please take a note of it. They'll ask you the difference between process and thread. So you can say process is heavyweight, whereas thread is lightweight. Process called an LWP. A process has its own memory, but threads share the memory with the parent process and other thread within the process. Inter-process communication is slower. That means one process want to talk to another process is very slower due to isolated memory, but here it's very faster. Inter-thread communication is faster due to shared memory. Context switching between the process is expensive due to saving the old and loading a new process memory and stack info. What happens here? You see, this is called context switching. What you are seeing now, look at the CPU, context switching is happening. So because of that, what you have to do before switching, you have to save the older registers and all, and then switch to the another one. So that is little costlier compared to the thread. So here context switching between the thread is less expensive due to shared memory and so on. Are you understanding, all of you? All of you? Hello?
Yes, yes.
Yeah, good. Okay, so this one also prepare this one and schedule. Linux has many other features like scheduling and preemptions, and we have a scheduler also. So Linux scheduler, a process scheduler, kernel control the way the task or process are managed on the system. The task scheduler, sometimes called process scheduler, is a part of the kernel that decides which task to run next. It is responsible for best using system resources to guarantee that multiple tasks are being executed simultaneously. This makes it a core component of any multitasking operating system. Okay, so this is the scheduler. Preemptions is also there. Concurrency and synchronizations properties also there. You need to know that. So yeah, this is your kernel. So at a high level, you need to understand concept of user space, kernel space, what is the role of kernel, how kernel is loaded when it kernel runs, process, thread, and stuff like that. Are you comfortable, all of you? Any questions?
Have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.